What's up guys, welcome back to the channel. In this particular video I will explain a very interesting problem which is Stickler Thief. This problem is really interesting guys, so make sure you stay tuned till the end of the video, and believe me, if you watch this video till the end then you will have complete idea about how this problem can be solved. Now without any further delay, let me start with the problem statement. So it says that Stickler the thief wants to loot money from a society having n houses in a single line. So we have n houses in a single line and n will be given in the input, right? So like this is 0th house, then first house, then second, then third, then fourth. Like this we have houses, right? Now guys, I'm starting from 0 here. After this we have, he is a weird person and follows a certain rule when looting the houses. According to the rule, he will never loot two consecutive houses or two continuous houses, right? At the same time, he wants to maximize the amount of loots as well, and the thief knows which house has what amount of money. After this, he is unable to come up with optimal looting strategy, so now he asks for our help. And now guys, now your task is to find the maximum money that he can get if he strictly follows the rule. Now ith house has ai amount of money present in it. So one example is given here guys, and let me explain everything using this particular example. So we have a thief, guys, right? And this thief wants to loot money from n houses. So for this example we have n equals to 5. This means that we have 5 houses. And see, if this is ith house, then the amount of money in this house is ai, right? So for 0th house we have a of 0 amount of money, which is 6. For first house we have 5 amount of money, then we have 5 again, then we have 7 for this house, and then we have 4, right? So this is the amount of money that each house has. After this, while looting the house, the thief has to make sure that he don't loot two consecutive houses, right, at the same time. So see, what he can do is he can start from this house, and whenever he loot any house, so he cannot loot the house just after that, right? So if the thief loots this particular house, so he cannot loot this house, then he can loot this house, right? So this is again a choice. So let's say he loot this house as well. So now this is the amount of money that he has. After this, he cannot loot this house, and let's say he loot this house as well. So again we have this amount of money from this house. So what is the total amount of money that the thief will get? This is nothing but 15, right? After this guys, there are multiple ways, like he can start from this house, then he can loot this 7 house as well, right? So he will have 5 plus 7 amount of money, which is 12. Apart from this, there are other ways as well, like he can first loot this particular house, right? After this he can loot this house, so this is also possible. So this way he's going to have 6 plus 7 amount of money, which is 13. So there are multiple ways like this, but the most optimal way is this one guys. This way is going to give the maximum amount of money to the thief. So 15 is going to be the output for this particular example. Now guys, I hope you have understood everything related to this particular problem. So let's talk about the solution now. Okay, so I have written one example here. And guys, from the problem statement, we can figure out one thing. For any house H, the thief has two choices. Either he can loot money from that house, or he can simply leave that house without looting any money, right? So these are the two choices the thief has. The question is, what happens when he loot money from a particular house, and what happens when he simply leave that house without looting any money, right? So in order to understand that, I'm going to use this particular example. So see guys, this H is basically representing a house, right? So let's say for any point in time, the thief is pointing to one of these houses. So let's say this house, this is ith house, right? I need a pointer to represent it. So the thief is pointing to ith house. Now see guys, for this house the thief has two choices. He can either stole money. If he stole money from this house or he loot this house, then he will get 12 amount of money, right? After this he can simply move to next houses, right? And he can get what amount of money he's getting from those houses. So whatever amount of money he's getting is definitely going to add it to this particular amount, right? After this, if he leave the house, then he can simply move to next house. So if this is house I, then he can simply move to the next house, right? What is the next house? The next house is I plus 1, right? So I'm simply going to write I plus 1 here. Guys, the values in the bracket are basically representing the indices, and the values outside the bracket are basically representing the amount of money, right? Now guys, this particular condition is not complete yet, right? So if he loot money, then see, from this ith house he can simply move to next house, which is I plus 1th house, as we have done here, right? But this is not true, guys, as the problem says that he cannot stole money from two consecutive houses. So if he stole money from this house, then he cannot stole money from next house, right? So there is no sense of moving to next house. So he will simply move to this particular house, which is next after next, right? So guys, this is I plus 2 house, right? So from this he will simply move to I plus 2 if he stole money from that particular house, right? So this is very important thing, guys, that we need to figure out. After this, let me take a smaller version of this example in order to understand the dry run. So first of all, I'm going to take n equals to 3, and what is the array? Array is nothing but first three values, right? So I have 9, then 4, then 12. Before I write the dry run, I need to write the function. So we are definitely going to have a function which contains I, then array, then n. Why I'm writing this, guys? This is very important to understand, right? Let me explain. So see, guys, the approach says that thief can simply move to every particular house starting from I equals to 0, right? So he can simply move to every particular house, and for every house he is going to have two choices like this. He can either store money or cannot store money, and whatever the maximum amount he get after after exploring all the possibilities, that maximum amount the thief is going to return, right? Because the main task of the problem is to find the maximum money that the thief can get, isn't it, guys? So now let me explain. So see, guys, I'm going to start with the dry run. First of all, the thief is going to start from I equals to 0, right? So this is I equals to 0, zeroth house. After this, the what he can do is he have two options, right? So if he stole money from this house, so he will get 9 amount of money, and then he can stole money from I plus 2 house, which is the second house, right? So whatever the money he get from the second house, and after every house after the second house, right? So that amount of money will get added to this particular value 9, right? And if he don't stole money, then he can simply move to the next index. So this is nothing but 1, right? So every value in a circle is going to represent an indices, right? So guys, after this, from house 2, again he has two choices. He can either stole money from the second house, which is 0, 1, 2, or he cannot stole. So if he stole, then he will get 12 amount of money, plus the index will now become 4, right? And if he don't stole, then index will become simply 3, which is 2 plus 1, I plus 1 for this case, right? After this, again he has two choices for this. If he stole money, then he will get 4, and he will move to 3 index, right? And if he don't stole money, then he will move to second index. After this, he has two choices again. He can do 12 plus 4, and he cannot loot the house. Then he will simply move to the third house, right? Now see, guys, from this we can figure out very important thing. That particular thing is this particular condition. You can see that I'm at index 3, but there is no index 3. Index 3 is something which is greater than n, right? Or equal to n. So whenever we have cases like this, so we can simply write 0, because he cannot get money from these houses, and not getting money basically means that 0 money will be added to this particular amount, right? So I have to write this condition. The condition is, if my I is greater than equal to n, then I can simply return 0, right? I will not get any amount of money, or the thief will not get any amount of money if the I is greater than n, right? Or equal to n. So now see, this basically means that 12 from looting the house and 0 from not looting the house. And from this we can figure out very important thing, guys. See, the thief is getting 0 money without looting the house, and 12 amount of money after looting the house. So what he should do? He should loot the house or not? He should definitely loot the house, guys. The reason is he is getting more amount of money here, right? And we are concerned about the maximum amount of money, right? We have to maximize the amount of money. So we can simply return the maximum of these two options. Let's say this is option 1 and this is option 2. So we can simply return at last maximum of option 1 and option 2, isn't it, guys? So this is the approach that we have. But hold on, what is the option 1 and option 2? So let me write the option 1 and option 2 as well. So what is option 1, guys? Option 1 basically says that loot the house, and if you loot the house, then this is something that will happen. So if he is pointing to ith house, then array of I will be added, like we have added this particular value, right, which is the money of current house. After this, I will simply move to I plus 2 house. Why I am writing I plus 2 here? Because the next house cannot be looted, because two consecutive house cannot be looted, right? After this, what is the option 2? Option 2 basically says that don't loot the house, simply leave the house. So at this particular point, the thief can simply move to I plus 1th index. Guys, this is the whole approach that we have to follow in order to get the answer, right? Now we are just left with the time complexity of this approach. And you can see that this is the recursive approach, and we have written like the base condition as well, right? So now we are just left with the time complexity. So see, if we have n houses, like we have 9, 4, then 12, then 6, then 12. So for this house we have two options, right? We can either loot or cannot loot. For this house, again two option, then again two option, then again two option, again two option. So let's say the size is n. So this is 2 into 2 into 2 up to n, right? Which is nothing but 2 raised to the power n. So these much operations we have to perform. Even you can see here as well, we have 1 2 3, right? So this is nothing but 2 raised to the power 3. So we have 1 2 3, then 4 5 6 7. This is nothing but 2 raised to the power n, like minus 1. So these are the operation that we need to perform. So the time complexity is O of 2 raised to the power n, and the space complexity is also same. Why? Because stack space also, like system stack also takes some space when we have a recursive approach. So this is the space complexity. Now guys, I hope you are clear with the like time complexity and the recursive approach that we have, right? But the time complexity is like very much. We cannot run this particular program for large inputs, right? So can we optimize this? Of course we can optimize this, guys, but the question is, can we apply dynamic programming here? Because whenever we have a recursive approach, then we have a doubt whether this problem contains repetitive subproblems or not, right? So let me explain whether we can apply dynamic programming or not. So what I have done here is I have written two important conditions for a dynamic programming, and once these two conditions becomes true, then we can apply dynamic programming, right? So see, the first one says that optimal substructure. Optimal substructure basically means that for every subproblem, the like for every problem the solution depends on subproblem. Well, this is true, right? We have already seen this particular thing. So for every problem the solution is basically dependent on the subproblems, right? So this basically means that the our given problem is following the optimal substructure. After this overlapping subproblem, so I have written a dry run here, guys. This is not the full dry run, but I think this is enough to explain you what the overlapping subproblem basically means. See, these are the only indices. We have 0 index, then we will move to 2 index if we include the house, and if we don't include, then we will move to 1 index, right? But I want to figure out one thing here, guys, that we have like repetitive subproblems here, right? So see, we are solving these subproblems again and again, right? But we can avoid solving these subproblems again and again, and this is what the optimization is about. So you can see that we have seen two important condition of DP here. So this means that DP can be applied in this particular problem, right? Or in this particular solution. So there are two ways of applying DP. The first one is memoization, right? The first one is memoization, and the second one is tabulation, right? So I will definitely explain each of them. So let me start with memoization first. Okay, so guys, memoization approach is also known as top-down DP, right? Why this is top-down DP? Because we first start from the whole problem, then we break down the problem into smaller sub-problems, right? This is how the memoization works. So see guys, memoization is nothing but optimization over recursive approach. What it says is, it says that first store every sub-problem, like the solution of every sub-problem, into some data structure. So let's say we have an array. And I think guys, instead of calling this array, if I call this DP, then it will make more sense. So this is basically an array and the name is DP, right? So this array is basically going to store solution to every subproblem. Like when I solve this subproblem, so I will basically store into the DP array, right? So guys, this is how we can like we can optimize the solution. First we store, and then before solving any subproblem, we will check if it is already solved. So if we move to left first, then you can see that we have already solved this particular subproblem, which is here, right? So we don't need to solve this particular subproblem again. We can simply return DP, the value from the DP array, right? So guys, this is how we can like optimize the recursive approach, and this is how the memoization works. I have written three important observations here. Each new subproblem depends on new value of I, isn't it guys? See, I can uniquely represent each subproblem with just a one value, which is I. For example, 0, this is a subproblem. This is a different subproblem. This is a different subproblem. This is a different subproblem, right? So each subproblem basically depends on value of I. After this, what are the values that I can have. So I can have values from 0 to n minus 1, right? So these are the maximum value of I. This means that we can have at most n unique subproblems, isn't it guys? N unique subproblem. Why I'm saying unique? Because I'm having repeated subproblems, but these two will be considered as a single subproblem, right? So we can have n unique subproblems, and we have to store every unique subproblem in the dp array. So we will create a dp array which has size equal to n, right? So I will make a dp array of size n, right? This is an integer array. So once I have made this array, then I need to pass this array as a parameter. So I will pass into this particular function. Then here I'm going to have dp, right? And here also I will pass dp while calling the function again. And guys, before solving any sub problem, I will write here dp of I equals to this particular solution, and then I will return, right? And guys, before solving any sub problem, I will simply write if dp of I is unsolved, right? Is unsolved. How we can represent the unsolved problem? So I can simply store -1 in this dp array. This is also going to work. Then I can simply return dp of I, right? This is how the memoization works. Let me show you the code guys, because the code will make it more clear. So I have written the code as well. This is the code of memoization guys. You can see here that in Python we have dp array first, which is storing -1 initially, and after this I'm calling this function, right? And this is the solve function that we have. And what's special about Python is we can simply define a function inside a function, right? This is the Java code. After this is the C++ code, right? So guys, you can see that this is the main function that we have, which is the solve function, and this is the condition where I am performing the optimization, or this is memoization step, right? I have not shown you the guys recursive approach. The reason is recursive approach is very similar to the memoization approach, right? So this is about the memoization, talking about the time complexity. So as we are not solving more than n subproblems, so O of n is the time complexity, right? And space complexity is something which creates a problem. Space complexity is O of n for simple using this particular dp array, and O of n because of the system recursive stack, right? So guys, this is something which is the time complexity and space complexity of the approach. And the problem is, if you try to run this particular Python code, then this is not going to work. The reason is, in Python we have a stack limit, right? So we cannot exceed that particular stack limit. So now I will explain you the tabulation approach, right? So let me show you the tabulation approach. Okay, so I have written the recursive implementation here, and guys, recursive approach is going to help us a lot. I will explain it, but first of all, see here. I have written bottom-up dynamic programming. So tabulation is also known as bottom-up dynamic programming, where we basically start from the base case and then we move to the solution to bigger subproblems, right? So first of all, guys, let me write the recursive relation. So what is the recursive relation that we have? Recursive relation we can figure out from this particular line. So it basically says that solution to any subproblem I is equal to maximum of uh, array of I plus solution to I plus 2. This basically means that looting the house, right? This is the condition where the thief is looting the house, and if we don't loot the house, then I plus 1. This is the condition, right? So whatever is the maximum of these two condition is the solution to I, right? This is the recursive relation. The tabulation approach says that we will create a dp array and we will fill the dp array, right? We will fill the dp array. So this dp array is going to have size n plus 1. Why I'm writing n plus 1? Because dp of n, we have to store 0 here. We have to store dp of n equals to 0, because this is what the base condition is, right? And how we are going to handle this particular case, I will tell you guys. So see, our tabulation approach basically says that at any point in time, dp of I will give the solution to I, right? This is what the tabulation approach says. So now I can modify this particular relation. Let me use red color here. So I can write dp of I is equal to maximum of array of I plus dp of I plus 2, right? Or dp of I plus 1. So guys, this is what the relation we have about the dp array. So now we just need to fill the dp array. See, we know one thing. Let me move here, guys. So dp of n is initially going to be equal to 0, right? This is the base condition that we have. And for greater than, guys, I am simply going to fill this particular value as well. So dp of n minus 1. See, let's say we have an array 9, 4, 12, 6, 12. So if I'm at this particular point, right? So what is the if I have only this house, just ignore these houses. So if I have only this house, so what is the maximum amount of money that I can get as a thief? So I can get 12 amount of money. So I'll simply write dp of n minus 1 is equal to array of n minus 1, right? Once you have filled these two like array values, so this condition will also get handled, right? We are not going to reach this particular condition at any point in time. So we are simply going to start from function. Okay, my bad guys, let me erase this. So we are going to start a for loop here. For I equals to n minus 2, then I is greater than equal to 0, then I minus minus, right? After this, inside this we can simply write this particular thing, dp of I is equal to maximum of array of I plus dp of I plus 2 or dp of I plus 1, right? Once we have done this, our dp array will get filled and we can simply return the answer. What is the answer? Dp of 0 will give us the answer, right? Dp of 0 basically means that what is the maximum amount of money that he can get after he loot all the houses starting from the last house, right? And guys, see, when I fill this particular value and I start from this particular index, then you can see that at most we are doing I plus 2. So I plus 2 will come to this particular value, which is 0, right? So we are not going to reach any condition where I will become greater than equal to 0. So guys, this is what we need to figure out. And once we have written this particular approach, our task is done. Now this code is something independent of recursive code, right? So the time complexity is O of n, space complexity is still O of n because of this particular array, but there is no space complexity due to the system stack, right? So guys, this is the whole approach. Now let me show you the code in tabulation. So this is the tabulation code, guys. Now I hope everything is clear to you, why we are writing n plus 1 here, why we are writing this extra condition here, right? So this is the Java code and this is the Python code. Now guys, I hope you have understood everything related to this particular problem. This is all about this video. Thank you.